Yo, this is Xist. Today we are looking at Xist CommonGame sample, which is a very simple game that when played just has this little ball that's bouncing up and down, and I can move around, I can look, etc. Okay, so I can also do things like change the time dilation. I can decrease it very, very slow. And now the ball's moving very, very slowly, and my character, as I'm walking around the world, this is all happening in slow motion. I increase this back to 1, everything's back to normal. This is normal time again, and I can go up to, quite fast, right? Oh my gosh, I'm just zipping around the screen now. So, and you see the ball is going quite fast up and down. So we also have now play and pause buttons. So when I pause this, you see time stops, and in fact I cannot move. I'm trying to move, that's not working. When I hit play, ball's back to going, and I have movement control again. So the maximum time dilation is 20. The minimum is not 0, it's barely above 0. And so there you go. We have also now, for example, the play and pause works not only through the menu, but also through the keyboard. So I can push the 1 key on the keyboard, and that's the same as clicking the play button. The 2 key is the same as clicking the pause button. And you'll notice when I click 1, the UI is responding. So the UI is listening for events and responding to keyboard events as well. So not only button clicks can start and stop time. There can be plenty of other ways to start and stop time, and the UI is responding to those system events. Anytime the user is pushing the escape key, then all the other UI layers are going away, except for this debug one, which I left here on purpose. But you see all this other UI is gone. And then we have our main menu. And this is all we can do is either resume game, and then everything comes back to normal, or we can quit game. And you notice I've chosen to leave the game playing in the background when we bring up the main menu, but this is a choice. You could pause the game if you prefer. So that's it. That's the game. It takes CommonUI and EnhancedInput as a base. It then brings in, importantly, from Lyra, CommonGame, and also CommonUser and the GameplayMessageSubsystem. It then plugs all of these things together and configures the game to use them the way that Lyra does. And that's it. It's an example. The CommonGame plugin is what allows the UI to work. So in this project, what I've done is I've put the CommonGame specific stuff, the assets anyway, here so that it's very easy to see what are these and why are these used. So this asset, all it does is say that the layout class that we want to use is this primary game layout, which is actually this one. And when we open this one up, you can see that this is just a widget with some common activatable widget stack layers. And if we look at the graph, I'm initializing this in exactly the same way as Lyra. So we have the game layer, the game menu layer, the menu layer, and the modal layer in increasing order of priority. So I'm putting our HUD, for example, here on the game layer, and the main menu layer is going here on the menu. So there's the only 2 layers currently in use in this project, but it does have all 4 just like Lyra does. So this functionality of having the different layers and being able to push content on and off the layers is extremely important. It's all done in CommonGame. In CommonUI, there are some other things that are also needed. For example, I have to set up this data table for forward and back actions, and then I have to set up this data table to say which entries do we want. Sorry, this is a blueprint. Which entries do we want from this data table? Plug that into CommonGame. Anyway, none of these things are particularly fun, but these are really important aspects of the UI, I think. And so here's where I put them. For the enhanced input configs, we have some input actions, look, move, time start and stop, zoom. And we have input mapping config. So we have mouse and gamepad for look and move. The HUD layout is probably named poorly. In Lyra, it's called a HUD layout because when you come in here, what you see is a whole bunch of UI extensions here. And then what they are doing is at runtime, they are generating the widget based on the configs and the extensions and lots of data assets. And it's a great system, but it adds a lot of complexity. And so what I've done is I've kept the concept that they've had of this is my HUD layout, but I've just made this a HUD widget instead. And so this is a HUD widget even though it's called a layout. And here we have the debugging, but the main pieces of this HUD are these buttons and then just some data that it's spitting back out. And another really nice thing about Lyra also is the gameplay message subsystem, which you can see I'm using here. In the HUD layout, when it's activated, one of the things that we are doing is we're hooking into the gameplay message subsystem, and we're looking on this channel, the time message event channel, for a specific type of message. And whenever we get one of these, every message received, we look to see was the verb of this message that the game was paused, and if so, then we set our UI that, hey, the game's paused, and if not that, then it was playing, and so we set our status to playing. And so every time we get these messages from the system that says it's now paused, it's now playing, we're changing the status here. And then, of course, when we're deactivated, we just undo this step. So these two steps, activate and deactivate, very important. And that allows the widget only during the time when it's active to be listening for these events, responding to these events. So very nice module. This should be just in Unreal Engine itself, but it's part of Lyra, so I pulled it out and I put it here. That's why I pulled it out and put it here. The main menu is a pretty simple widget. It kind of blurs the background a little bit. It also includes this CommonUI debug widget just so we can see. But basically this just has the two buttons, resume game and quit. And very, very simply, resume game just deactivates the main menu and the quit button quits the game. So super simple. This main menu class is actually part of the HUD layout config. Here it is. So in the HUD layout, when this HUD is active and the user pushes escape, we're going to show the main menu class, which is this class here. So two different widgets, but the HUD connects to this widget as a dependency of sorts. Here in the UI foundation, there's an Xcgs button blueprint, and this is pretty important. This is our base button class, which is pretty easy, but derives from Xcgs button base, which has some code in it, and it ultimately derives from common button. On the graph here, you see this code, which is responsible for allowing the button to respond to different events and have those rollover effects and all that kind of stuff. So I got this out of Lyra. In the player folder is the player pawn blueprint, which is based on the Xcgs player pawn C++. And the main thing that this thing does is it configures the pawn. So we're configuring which HUD are we going to show when the player is possessing this pawn, which input mapping contexts are going to be available. There's only one, and what are the input action maps to map the input actions from the editor to C++ tags. So these things are very important. I did also add a floating pawn movement, and here's, for example, is the action map. I look is this tag, I move is this tag, start is this tag, etc. What I'm going to do right now is I'm going to go through this part of the README, the interesting code part, and you can follow along in your own editor if you have one, or just watch this. So the Xcgs player pawn. There are some really important things happening here. On possession and unpossession, that's when we're swapping the HUD in and out. We're swapping IMCs in and out. And then when the player gets restarted, which happens as the player joins, then we're binding to enhanced input. So all of these things are happening in the C++. Like Lyra, you must provide a C++ map of input action to gameplay tag. So let's take a look at the player pawn C++ class. You can see here I've added the inputs that we have to configure, and we do configure these in the blueprint. But then we're handling possession, unpossession, setting up input, and we have specific input handling functions here as well. So the C++, I guess let's start at the top. This is just camera zoom management here. On possession, we are pushing the HUD layout to the game layer for the local player. And then we're also clearing any existing input mappings from enhanced input, and we're adding one at a time the input mapping context in increasing priority. So on unpossessed, we undo that stuff. When we set up the input component, this looks kind of similar to UE4 code, but this is how we're doing it now. So we map the input tag, which that asset, the editor asset tells us is IA look is the same thing as input tag look. So here what we're doing is matching that one every time it's triggered to this input look method, which just adds controller pitch or yaw. So you can go through this in a lot more detail, but this is a very important class. And rather than have it be spread out all over the place in different components and different data assets like Lyra has, I've centralized it all right here into player pawn. So player pawn, very important. Xcgs activatable widget. So the important part of this thing, this is the base class for all widgets that I'm using. All of my widgets are activatable widgets. And it gives a custom result from here. So let's just go ahead and take a look in get desired input config. Now you may need to change this. In fact, you will likely need to change this, right? You have full control over this. What are the values here? These are the Lyra values. Change nothing, change it to be game and menu, change it to game only, change it to menu only. These are the Lyra values. And because all of our widgets are Xcgs activatable widgets, all of them will inherit this get desired input config, which is going to give a different config depending on whether the input mode is game, menu, or game and menu, or the input mode is don't change anything, right? Which that's this result is the don't change anything result. So also very important. Now the HUD layout is an activatable widget, and it's more a widget than a layout, okay, because I'm not doing UI extension. You could potentially upgrade that, you could add it, you could make your own UI extension. For now, for simplicity, I don't have UI extension, but still this widget is very important. Why? Because of this, on native on initialize. Here's where we hook into CommonUI, and we tell CommonUI anytime the user issues the main menu UI action, we want to call this method, which is here, which just says push the main menu class to the menu layer for the local player. So very important that our HUDs derive from this class to get that functionality. And then the next one is the main menu widget, which again has native on initialize, but also has on activated on deactivated, and does some extra stuff. But here again, look, we're hooking into CommonUI. Again, the main menu UI action, and calling our own method when we get that action. So these are part of bringing in CommonUI and making the game aware of them, and then using a good CommonUI base for your other widgets. Make sure you look through these configs. I've tried to minimize these as much as possible. for example, here in default editor, the only stuff that I have in here is, hey, look, we're configuring CommonUI. Default engine has some important ones. These are very, very important. These are very, very important. Let's see what else we have. Default game, these are very important. And default input, these are very important, and these are very important. Without these INIs, this stuff just isn't going to work. Like, okay, great, you have the code, but it's not active, it's not doing anything. And so this can be one of the tricky parts of understanding Lyra is going, what even is happening? Well, here it is, you know. So this is it in simplified form. These are the configs that are activating the code. Here's how the code is running with all the multiplayer stuff turned off, etc. If you made it to this point in the video, it's time for an apology. When I made this, I made it on my custom 5.3 engine, thinking that, great, I can just share the stuff with you, no problem. But even 5.3 Preview 1, which is now available in the launcher, will not open this project. So I imagine that you'll have to wait for 5.3 to actually release before you can open this in Unreal and compile, etc. The workaround is, you can see I have the engine association set to XUE53, which is my custom 5.3 engine. So if you have a custom 5.3 engine, just change the association and you're off and running. But there is no 5.3 release right now, and unfortunately it seems like you have to wait for 5.3 release until you can open these project files. So I'm sorry, in the future, I know that this happens, and so I'll release videos for current versions of Vue rather than future, but for now this is a Vue 5.3 required project, and 5.3 Preview 1 doesn't work, so apologies. That being said, if this video doesn't suck, like, subscribe, share with someone who might find it interesting. Have a nice day. Happy developing.